solve for your vertex. So that was a revenue problem. Let's take a look at a number problem. One number is 3 more than another number. Find the two numbers such that the difference between them, difference between the square of the larger number and 2 times the square of the smaller number is a maximum. Well, first, I need to think of what the numbers could be. If I said I have one number and I called it x, and one number is 3 more than the other, well, then the other number I can call 3 more than that, x plus 3. If I'm taking the difference between the square of the larger number, x plus 3 squared, difference means subtraction, 2 times the square of the smaller number, 2x squared, then that's going to be a maximum. Well, anytime I say a maximum or a minimum, it's going to equal y. If I'm solving for a maximum or minimum, I'm solving for y equals, and then I need to find what my q value would be. Now, I need to expand and combine this before I can even start completing the square. So, I'm going to say that if I'm expanding and combining this, y is equal to, well, x plus 3 squared is going to be x squared plus 6x plus 9. And I'm taking away from that 2 x squareds. I combine the like terms, and I get y is equal to negative x squared plus 6x plus 9. Now I can start completing the square. Y is equal to bracket negative x squared plus 6x, close a bracket, and then plus 9. When I take the negative out, it's going to become x squared minus 6x, and then plus 9. Y is equal to negative bracket x squared minus 6x plus a number minus a number, and then plus 9. Well, half of 6 is going to be 3, and 3 squared is going to be 9. Y is equal to negative bracket x squared minus 6x plus 9. And on the outside I have plus 9, and the negative 9 times the negative 1 to move it out is going to be another plus 9. Square root the brackets, negative bracket x minus 3 squared. And combine the constants, 9 and 9 are going to be plus 18. So the maximum here is going to be 18, and this occurs when the x value is 3. Well, if x was my smaller number, then I can say that the smaller number is 3. The larger number was equal to x plus 3. Well, 3 plus 3 is going to equal 6. So the smaller number is 3, and the larger number is 6. The other very common form of these problems is what's called an area or perimeter problem. So in this case, a garden plot in the shape of a rectangle is divided into 3 sections by constructing 2 fences parallel to the width of the garden. A total of 100 meters of fencing is available to enclose the entire garden as well as to divide it into its 3 sections. Find the dimensions of the garden that will enclose the largest area possible. Well, first, I'm going to say that I have my length here, and then parallel to the width, I'm going to split it into 3 sections, which means that if it's parallel to the width, suddenly I have 4 fences along this way that are all the same length, and I have 2 along the length that are the same length. So I actually have 6 fence sections. Well, I typically like to use X for one of them. So in this case, I'm going to say that the width is going to be represented by X. I know that to make all these 6 fence sections, I only have 100 meters of fencing, which means that in this case, that 100 meters has to account for the 4 X lengths and the 2 L lengths. Now, I'm going to solve for what the L would be, and you'll see why in just a second. I'm going to move the X's over, and I'm going to divide by 2. Now, why did I do that? The reason is because I'm trying to find for a maximum area. If I know that area is equal to length times width, and I know that anytime it says maximum or minimum, I want that to be my y, then I'm going to have to look at the other 2 things. Well, I'm not going to say that I'm going to do X times L because suddenly I have too many variables. But if I use the perimeter or the amount of fencing that I used, I can isolate L so that L is going to be represented by how many X's it is going to be. In this case, L is represented by 50 minus 2X. So I'm just going to substitute that in. I'm going to say that Y is going to equal X times 50 minus 2X. And when I expand this out, Y is equal to negative 2X squared plus 50X. Then suddenly I have my quadratic, and I can complete my square. So I'm going to bracket off the X's, and I'm going to divide the negative 2 out. Negative 2 bracket X squared. 50 divided by negative 2 is going to give me negative 25X. Y is equal to negative 2 bracket X squared minus 25X plus a number minus a number. And half of 25 is going to be 12.5. When I square that, I'm going to get 156.25. Now, I'm going to move the negative 1 out. Y is equal to negative 2 bracket X squared minus 25X plus 156.25. And then when I multiply the negative 1 by negative 2, I'm going to get plus 312.5. Y is equal to negative 2 bracket X minus 12.5 squared plus 312.5. I'm going to get a maximum area of 312.5. And that is when the dimension of X is 12.5. Well, if x is equal to 12.5, if L is equal to 50 minus 2x, 50 minus 2 times 12.5 is going to be 25. And because this is all in meters, I can say the dimensions are 12.5 meters by 25 meters. And there's my answer.